So I want to give you all a little bit more guidance with some of these problems, and we can walk through them together. Make sure you have your assignment out, and we can discuss these problems from class today. So here we want to decide whether or not these triangles are congruent, and they are because FH is congruent to FH. So this shows the reflexive property. However, the triangles are congruent through side, side, side postulate. So we have GFH is congruent to JFH. Here again, DF is congruent to DF through the reflexive property, but the triangles themselves are congruent through side, angle, side, side, angle, side. Notice how the angles between the two sides, the congruent angles are between the two sides. So we have triangle CDF is congruent to triangle EDF. Okay, then this last one, again, we have the reflexive property. But we have a side, side, and then an angle. And this angle is not included between the two sides, so there's no congruence here. Remember, no SSA or ASS. This postulate cannot be used to prove triangles are congruent. Even if they look like they're congruent, we're not given any other information to disclose that they are congruent. So yes, if we knew that these smaller angles were congruent in here, then we could prove through angle, side, angle, but we don't know that. So you can't just draw anything that you don't know. Okay, let's look at this one. So we have a side and then an angle and an angle. So remember that third angles theorem tells us, ooh, this third angle is congruent. So we have a side, angle, side, or sorry, angle, side, angle. So with what was just drawn, this postulate, angle, angle, side, is that shortcut. So if we started at B and went to A and then C, we have to start at D, then go to A and then C. Okay, for the next one, side, angle, side. So we have CBA, it's congruent to FED. The next one, we have a right triangle, and then we have this hypotenuse, or sorry, this leg that's congruent. And we don't know any other information besides these angles. So we have an angle, another angle, and then we have a side. So through angle, angle, side, we can prove that these are congruent. We don't know any other information about the sides, but through angle, angle, side, we can show that triangle STU is congruent to triangle VTU. Okay, and looking at this, we have these right angles are congruent. We have the sides are congruent, and look, we have another set of angles that are congruent. So angle, angle, side again. So we have triangle DCE and triangle ACB are congruent. Okay, for the next one, we have right triangles. So maybe this would be a right hypotenuse leg. We have the reflexive property here. So we have a right angle, a hypotenuse, and a leg. A right angle, hypotenuse, and a leg. So these triangles are congruent through RHL. So HEF is congruent to FGH. So we can't prove that these triangles are congruent right away through angle, angle, angle. But look, we have a reflexive property here. So do we have angle, side, angle? Angle, side, angle? We sure do. So we can say MJL and KLJ. Okay, sketch LMN and STU, mark the triangles with the given information. So LNM is a right triangle and TUS are right. So LNM, TUS. And now we have LM is congruent to TS and TU is congruent to LN. These triangles are congruent through right hypotenuse leg. We have these triangles. Okay, so LM, N. LM is perpendicular to MN, and then ST is perpendicular to TU. So we have right triangles here. And now we know, all right, LM and ST are congruent, LN and SU are congruent. So again, marking up what we know, these triangles can be congruent through right hypotenuse leg. So just having us remind us of this RHL. Okay, what congruence is needed to show that the triangles are congruent? Use that congruence to tell which reason postulate you would use to show that the triangles are. So we would need to know, looking at this, we have an angle and a side. So we would either need to know another angle or another side. So here's one possible thing that we could know. We would need to know that GH is congruent to LK. And this would help us prove side angle side. Okay. Here we have the reflexive property, so we have a hypotenuse. So if we knew a leg, so if we knew PQ and SR were congruent, we can use right hypotenuse leg to prove these are congruent. So we need a bit more information here. We would need to know about WX and ZX, and we have this angle here. So if we knew the sides, then we can prove congruence through angle, side, angle. Okay, so determine which postulate can be used to prove the following triangles congruent. So here we go. What do we think? Side angle side is the postulate. Here, right hypotenuse leg. Here we have angle, angle, side, where the side is not included between the two angles. So now some proofs. We need to make sure that we're marking up the diagram as we go. So if AB and BD are congruent, and then we know that BC is perpendicular to AC. So we know that we have two right angles. So let's write our given. And then from there, we know that angle ABC is congruent to angle ACB is congruent to angle DCB, because all right angles are congruent. And the other day we called this the right angle theorem. But if you write all right angles are congruent, that's perfectly fine. So we have two pieces of information that are congruent. We have a side and an angle. The third side that's congruent is BC. So we can say BC is congruent to BC. And this is through the reflexive property. Now, do we have enough information to prove these triangles are congruent? We have right angles, right? We have a leg and the hypotenuse. So we can prove that triangle ABD is congruent to triangle BCD because of right hypotenuse leg. So you always want to look for three pieces of congruence, right? Three pieces of congruence. So we have a right angle, we have a side, and another side. Okay, so this one, if N is the midpoint of MO, then we can mark those congruent. And then LM and OP, then we know LN and PN. So we want to prove these triangles congruent. We have all three sides, so we know it has to be side, side, side. So if N is the midpoint of MO, LM is congruent to OP, and LN is congruent to PN. That's our given. But we only have two statements that show congruence, these two sides. So let's see. If N is the midpoint of MO, we can say that MN is congruent to ON, because this is a definition of a midpoint. Now can we say the triangles are congruent? Yes, this is our third piece of congruence. So we have triangle LMN congruent to triangle PON through side, side, side. So even though the given is saying that n is the midpoint, we want to show congruence.